Hi, welcome to the lecture series on IC fabrication. Here in this series, basically, I will cover how basically we manufacture IC. These are the outlines of my lecture sessions. In the first session, I will cover about introduction to IC fabrication, then how basically we fabricate ingot from basic raw materials like sand, etc. Then we will talk about how can we fabricate wafers from the ingot. Then we will discuss the NMOS fabrication steps and CMOS fabrication steps. And in last session, I will cover all the major steps in some more details regarding IC fabrication. So let's start. In this first session, introduction to fabrication, I will basically cover the following: a look inside, clean room, major fabrication steps, and state of the art technology as of now. Okay, so let us start. And before starting, first of all, a question comes in our mind that what we are going to do and why should we do it. So first of all, what we are going to do, we are going to discuss the IC fabrication. And what is IC fabrication? IC fabrication is the process of manufacturing different ICs in industry. So we are going to see how basically ICs are fabricated, what are the different steps. Okay, and why should you know it? Anyone who is interested in this area, as well as students or other people who are related to electronics core field, they must be aware of how basically any IC is manufactured in industry, right? So let us start. First of all, just have a look inside whether you have seen any IC. Whenever you have seen any IC, whether you have removed the main cover and you have seen what is inside this box, whether you have opened this. Now let's open it. If we open this box, you will find that here there are two parts. This small portion is basically is your main chip called as die, core, called as core, and the outer side is called as die. So here we have two portions. Inside is the core and outside is the die, where core is the main area. The core where the chip is fabricated. This is that core, right? All the fabrication steps take place onto this core. Different MOSFET, different elements are fabricated onto this. So, and what is the purpose of this core basically? This core is for the purpose of connecting this chip with the external world via these pins, and for the purpose of passivation and packaging of this chip. Okay, so we will see it later on in detail. You can have a look once again that how basically IC will look like when we open its top module. This is the main core, and these small lines are the bonding lines, bonding pads, which are connecting it to the external pins. Okay, the same diagram shows here, showing this is the core which is connected with these pins here to the external world. This is one more diagram of Intel processor. If you open it, you will find the main core just in the middle of this complete die. Okay, and these are the pins connecting it to the external world. Now let's see what this person is showing to us. This person is inside the IC manufacturing plant, is showing us a circular disc, right? This is that circular disc, and what is here inside the circular disc? This circular disc is basically called as wafer, onto which we basically fabricate our chips. And if we see it, here are a number of similar things are shown here, right? So what is basically this is this one small portion. This one small portion is containing one set of core and die. Okay, and so in one wafer we are having a number of cores and dies, right? So these are fabricated at once. You can have a look here that if this is our wafer containing a number of this is only one portion, right? Similarly, this is our another portion. So this is only one set of core and die, which is again shown here. This is one set of core and die. This is your core as written here, and the upper portion, the outside portion is your die. So basically this one set, one core and die makes one chip, and so we can say that a number of chips are fabricated at once onto one wafer, right? So whenever the fabrication process takes place, a number of wafers are taken place at once, and at one wafer, if we talk about only one wafer, a number of cores and dies are there onto that wafer. So a number of operations take place on a number of wafers, and on one wafer a number of cores and dies are there. And if we see inside one core, if we see only inside only one core, then there is a number of MOSFETs. A number of MOSFETs are present inside one core. Million or billions of MOSFET are there inside one core. So you can imagine that onto this wafer how many numbers of transistors are existing. Even we are saying that one core is having a million or billion of MOSFET transistors, then how many transistors are there onto this wafer? And a number of wafers are taken at once for processing, right? So this is how what basically called as batch processing. So operation take place at once. Now we will look after about the different type of operations later on. This is just the introductory part to give you an idea what basically happens. Okay, so what happens after fabricating number of cores and dies onto one wafer is that we cut it and we take out separately different core and dies. Okay, so one core and die is shown here. You can see that this small die, small core which has a number of circuits embedded onto it, and then on over the core there are the bonding pads, and these connections are there to connect it with these pins which connect this core and die with the external part. Now this operation is still not complete since it is open from the top. So what we do, the next point is to package it. Okay, and after packaging our IC is ready, and then it is now tested whether it is working properly or not. And if it is working properly, the testing is okay, then we send it to the market. So fabrication, packaging and testing is the final stage, and then the chip is ready for the market. Okay, we will look into the detail of the steps. Now first of all, just have a look inside the chip manufacturing plant. If we see just this diagram, this picture, what we notice first. Okay, let me take one more picture. What do you see? What do you observe in these two pictures? At the very first look, what we basically see, what I observe is this. That why these people are covered so much? What is the purpose? I am afraid nowadays because of corona. So is this corona? They are maintaining social distancing and packing themselves so much. No, my dear, this is not true. This is not because of the corona which is nowadays, right? The reason behind this is something else. The first requirement of any VLSI industry is the cleanliness of the entire room. The clean, perfect clean environment. And clean means, I will tell you what is the cleaning meaning. Okay, but first thing we should keep in our mind is that the first requirement is the cleanliness of the entire room. And also the highly purified wafer is required for fabrication. What does the cleanliness mean, and what is the highly purified wafer? We will discuss it shortly. Okay, but first of all, we should keep these two things in our mind. That highly purified wafer is required and cleanliness of room is required. But note one point: I have mentioned here this cleanliness requirement is not a part of our Honorable Prime Minister Swachhata Abhiyan. Do not confuse with that. Okay. So what basically is the requirement? What is the reason behind this cleanliness requirement is that actually all chemical operations take place onto the entire wafer at once, which we have just seen. Okay, all chemical operations take place onto the complete wafer entirely, entire complete wafer at once, and simple amount of small amount of dust particles may contaminate and damage the whole wafer, and hence all the IC manufactured will be waste. Okay, so that's why the cleanliness of the room is required. Okay, now what does the clean room means? You can search on the YouTube for different clean room environment and structures, which will tell you what basically the clean room is. This is one side which will give you in brief that what basically a clean room meaning is. Okay, I will not go into the onto this side. You can see this. I will show only one point to you, that how basically we classify the standard of class any clean room. So the clean room standards are here in front of you, which are given on this side. That ISO 1 ISO standards are there: ISO 1 class, ISO 2 class, ISO 9 class. You can see that as per the definitions how much number of dust particles are allowed inside any clean room as per the standards are written here with the size of the dust particle. The size greater than 0.1 micrometer for ISO 1 standards, only 10 particles are allowed, up to 10 particles. And if we talk about greater than 5 micrometer, no particle is allowed for ISO 1 standard, 0.0029 only. Okay, so this is how you can imagine that how much cleanliness is there inside any clean room. So now let's talk about the major fabrication steps. If we see what are the major fabrication steps, we start from the basic raw materials like sand, etc. We form the ingot, then wafer is prepared, epitaxial growth, oxidation, diffusion or ion implantation, metallization, mounting, packaging, wire bonding, encapsulation, and final testing are the main steps in any IC fabrication. Okay, process. So let us understand it more in a better manner with the help of some pictures in a pictorial view. Sand. First step, as we have said, that we start from the sand and some other raw materials. Okay, from sand we basically obtain, this is what, quartzite, purified form of sand. Okay, then we obtain from it this, what is this is here is basically known as EGS, electronic grade silicon. Okay, and this electronic grade silicon basically is what, silicon which is 99.999999% pure. Okay, so this is what the silicon only with 99.99999% purity. So it's called as electronic grade silicon. Then from this electronic grade silicon we basically form this, which is known as silicon ingot. Looks like a pen, but it is not like a pen. In size it is huge enough, more than 10 feet. Okay, so this is known as silicon ingot, a huge cylindrical shape structure, and from this, after cutting it, we obtain the wafers, these circular discs known as wafers, onto which different operations take place, as I told you in the starting. And I told you that a number of wafers are taken place together, that means batch processing takes place, and onto each and every wafer different chemical operations take place, a number of operations take place, and finally we obtain this wafer after fabrication. Then we cut and take out all the dies and cores separately, and then we package and we find finally the ICs separately. So this is in brief about the major fabrication step. We will go into the detail one by one later on in the later sessions. Okay, this is one video, and there are various other videos also on YouTube and other from other sources also, where you can see that how basically fabrication take place in any IC industry. Okay, so you can go and you can watch the video whenever you can get some time. Now the next point of our discussion is what is the state of our technology. That means which is the latest nanometer technology device that has come into the market, and what is the device. Let us be aware about that. Few people say that it is 14 nanometer technology in the market, few says 10 nanometer in the market. In this 2020 till now, yes, Intel is making processor up to 10 nanometer, it's correct, but devices are manufactured by other companies for up to 5 nanometer also as of June 2020. Okay, if we have a look here, MOSFET scaling process nodes. In 1971, we were having different chips with 10 micrometer technology, and in 1974 6 micrometer, 1977 3 micrometer, and in 1981, that means in a decade from 1971 to 1981, we reached from 10 micrometer to 1.5 micrometer. Okay, and now where we are, 4 decades have been passed after 1981, and where we are at 5 nanometer. Let me show you. This is I have taken from Wikipedia. Okay, from Wikipedia you can see about 7 nanometer process. They have mentioned that TSMC, Taiwan Semiconductor Manufacturing Company, began production of 256 megabit SRAM memory chips using 7 nanometer process in 2017. Okay, and TSMC began mass production of 7 nanometer devices in 2018. Okay, and other companies like Apple Bionic, right, August 2018. Huawei also announced 7 nanometer processor before Apple in 2018. So in 2017-18 we started with 7 nanometer technology. But what about the present condition in 2020? You can see on the website of Qualcomm, as per the statement of February 2020, we are talking about this 5 nanometer technology. You can read it here. Snapdragon X60 is the world's first 5G modem RF system based on the leading 5 nanometer process node. So up to 5 nanometer we have achieved devices. Okay, and soon we will go below 1 nanometer. Okay, so this is all about the today's presentation. What we discussed today about what and why about the IC fabrication, introduction to IC fabrication. We talk about a look inside a clean room, the major fabrication steps, and the state of art technology. In the next session, we will start our discussion with the fabrication of ingot from sand. Okay, till then, thank you for your patience.